This podcast is on section 3.2. We're going to take a look at slope again, something that you've looked at in other previous courses such as geometry and algebra. So we'll start with this problem right here as a warm-up. Suppose you are taking a long trip in your car. At 5 p.m. you notice that the odometer reads 45,623 miles. At 9 p.m. you notice that it reads 45,831 miles. You find your average speed during that time period by dividing the difference in distance by the difference in time. All right, so here's a definition of slope. Definition of slope is rate of change. Okay, so here we're dividing the difference in distance by the difference in time, and that'll tell us our average speed. Okay, so for this car trip, the difference in distance, we're going to take our larger distance, 45,831, subtract the 45,623, and we traveled that distance over, we went from 5 p.m. to 9 p.m., so we went 4 hours. Okay, so if we simplify that, we're going to get 208 miles that we traveled in 4 hours, and that turns out to be 52 miles per hour. Okay, so there's a review of slope, a rate of change, and in this example, you're going 52 miles per hour. Here's a formula that you should have seen in geometry. The formula for slope between any 2 points, x1, y1, and x2, y2, is the change in the vertical, y2 minus y1, over the change in the horizontal. And x1 cannot equal x2, and the reason is if they're equal, you'd have a 0 on the bottom. And we know that if you try to divide by 0, it's undefined. Okay, so slope is rise over run. Or you can use this formula right here. Okay, so here's kind of a picture of that last example. We figured out the rise over the run. Okay, more review of slope. What does a positive slope look like? A negative, a slope of 0, and an undefined slope. So positive, and we read slopes from left to right like we're reading a book. So positive would be going up from left to right. Negative would be going down from left to right. A slope of 0 would be flat, because we're not, it's rise over run, we're not going up or down any, so it's a slope of 0. An undefined slope would be straight up and down, and this is an example of where you'd have a slope formula where a 0 would be on the bottom, and again, if you try to divide by 0, it's undefined, we don't know what it is, and so there's an undefined slope. Intercept form of a line, you've probably seen this before. Y equals mx plus b. In this book, they define it a little bit differently. Y equals a plus bx. And the reason why they do this is intuitively, b is your y-intercept or your starting value. So usually we start our starting value, and then we go up or down the slope, and that's why they write it in this order. They have the starting value first, which makes sense, and then b would be the slope then. So you might see it either way, y equals mx plus b, or y equals a plus bx. It means the same thing. Notice in both cases, slope is the letter next to the x. So that's how you can define your slope. And the number by itself, or here in this case letters by itself, would be the y-intercept. And the y-intercept again is the starting value when time equals 0. Okay. The dependent variable is usually the y. The independent variable is usually the x. An example is speed and fuel economy. The fuel economy is dependent because it depends on the speed or how fast you're going. So again, the independent is usually x, the horizontal. The dependent is usually the y value, and it's usually the vertical. And in this case, the fuel economy depends on the speed. Okay, we have two new words here, domain and range. Domain are all possible x values. So we're looking at the independent variable here. Range then would be all possible y values. In this case, we're looking at the dependent variable. I'll give you an example. So the domain for this fuel economy and speed example, the domain would be, we're looking at speed here. I should use a different color. So here's the units, speed, units of measurement. And as you can see, the speed starts at 5 and goes to 75, and it can go above. So the speed would be 5 miles per hour and greater or above, and that's the domain. So positive numbers, 5 and greater. The range is the fuel economy, and it looks like it starts at 0 and can keep going up from there. It looks like it's between 0 and 35. Notice there's no negative numbers and so on, so the range between 0 and 35. Okay, so the domain is the units for the x value, range is units for the y value. Okay, let's talk domain and range here. So independent and dependent variable, again, independent is here. Usually the x, the horizontal axis. So independent variable, so here the domain, all right, would be from starting at 1 and going to 79. We're going to say positive numbers. The unit of measurement is months, so the domain is measured in months. The range here is downloads. In this case, from 0 and greater, so x or y values can be greater than 0. Okay, so range is what are the y values, and domain is the x values. Okay, what is the domain and range of the file? Okay, now we have equations instead of graphs. So remember, domain is the x value. Okay, just think, are there any x values that you can't plug in here and get an answer? And there's not. So the domain is all real numbers. You can plug anything in for x. So we can say all real numbers. A real number is anything that any number you can think of on a number line. Decimals, fractions, whole numbers, positive and negative numbers. Those are all real numbers, and you can plug anything here to get an answer. And then the range then would also be all real numbers. You can get a fraction answer, you can get positive, you can get negative answers. Another way to write all real numbers is this double R right here. So that means all real numbers. How about the next one? What is the domain and range of the following equation? Y equals x squared plus 1. Well, again, you can plug in anything for x here, any decimal, fraction, negative number. So the domain, again, is all real numbers. But let's talk about range here. What will not happen for the answer if we're squaring this number? Okay, so think of what doesn't happen. If you have a negative number in here, what happens when you square? It turns positive. And so your answer here is going to be positive. Anything, and we're going to add 1 to it, so you know that it's going to be any positive number, 1 and bigger, because the lowest number we could get here then would be 0, and 0 plus 1 is 1. So here the range would be any numbers greater than or equal to 1, because 1 would be the smallest number we can get here. Okay, let's talk about domain and range with a word problem. So let's say we have Darren, his car gets 20 miles per gallon of gas. He starts out with a full tank, 16.4 gallons. As Darren drives, he watches the gas gauge to see how much gas he has left. All right, first step, identify the independent and dependent variable. So you're thinking, what depends on what? Okay, so in this case, the amount of gas depends on the miles driven, the number of miles driven. So here's one way we could define this. Okay, so the more miles, then the more gas that he uses. So if we define it as this, then state a domain and range. So domain is x values are independent. All right, so a domain then would be, well, anything greater than 0, right? Because you can't go negative miles. So we could say x, or number of miles driven, has to be greater than or equal to 0. The range is the amount of gas. So again, anything greater than or equal to 0 would work. Can't have negative gallons of gas. C, write a linear equation in intercept form to model this situation. So y equals a plus bx. So we're thinking starting value and rate of change. All right, so he starts with 20 miles per gallon right here. Oh, he starts with 16.4 gallons in his gas tank. And we have to figure out his rate of change. He gets 20 miles per gallon. So the rate of change here, we have to figure out how far it decreases per mile. So 20 miles for every 1 gallon. So 1 gallon every 20 miles. If we simplify that, that's 0.05 gallons per mile, because here gallons is on top and number of miles. So there's your rate of change. So it goes down 0.05 gallons per mile, and there's your rate of change, and then times x, and x is number of miles driven. So there's your equation. How much gas will be left in Darren's tank after he drives 175 miles? So number of miles driven goes in for x right here. So if we plug in y equals 16.4 minus 0.05, plug in the 175, and if we calculate that, we get about 7.65 gallons. Part E, how far can he travel before he has less than 2 gallons remaining? Okay, so for this one right here, we want to put a 2 right here, and then we're going to solve this algebraically. Okay, so when you're solving a problem like this, we're going to subtract first and then divide, and you'll end up getting x equals 288 miles that he can go before he has less than 2 gallons. And again, that you just solve algebraically. Okay, your assignment then, due tomorrow, is section 3.2, so label it, page 134, and you'll be trying these problems right here.